Body mass index, or BMI, is a foundational health metric used by doctors and insurance companies to assess an individual's risk for cardiovascular disease and other chronic conditions. But collecting this measurement at a population scale presents a massive logistical hurdle. Relying on physical scales and tape measures is slow, tedious, and difficult to scale across millions of patients. When organizations try to bypass the hardware and ask people to self-report, the data becomes wildly skewed. Studies consistently show that individuals underestimate their weight and overestimate their height. As a result, the modern health industry suffers from a massive data gap. Accurate BMI collection as it exists today is simply too slow and invasive to be continuously useful. To solve this, computer scientists are testing a different approach, replacing physical medical hardware with automated facial geometry analysis. This face-to-BMI prototype uses a simple set of action buttons to test if software can replace a physical scale. We'll test drive this interface, monitoring the blank status window below to track how computer vision extracts medical metrics. Turning a standard computer into a diagnostic tool requires marrying this straightforward user interface with a complex deep learning engine behind the scenes. The process starts as soon as we click the Generate and Load Models command. Immediately, the software reaches into its backend and loads localized face detection libraries into active memory, logging the successful connection right here in the status box. Next, the system boots up the heavy lifting components, convolutional neural network architectures, specifically utilizing deep learning models like ResNet or ExceptionNet. These networks are not starting from scratch. They carry pre-trained weights, meaning their algorithms have already analyzed tens of thousands of labeled public faces to learn how biological features correlate with physical weight. This initialization step gives a standard laptop the visual diagnostic experience of thousands of prior medical observations, ready to be applied to a new patient. With the engine loaded, the next step is providing the data. We upload a standard single-shot test photograph into the system. The interface logs the specific file path, confirming the image is securely locked into the processing pipeline. Before the AI can calculate BMI, the computer vision tools have to prep the image. The software strips the photo down to grayscale and deploys a Haar cascade algorithm, a detection method that scans across pixels to isolate the face. Once found, the software crops the region and forces it into a strict 224 by 224 pixel matrix. This standardization is required because deep learning networks cannot interpret raw, varied photographs. They need perfectly uniform grids of data to function without throwing errors. Now we trigger the final step, hitting the Run Face and BMI Detection Algorithm button. Inside that precise pixel grid, the neural network begins hunting for specific biological markers, measuring the exact facial width, the underlying cheekbone structure, and the sharpness of the jawline definition. The model maps these features using a well-documented physiological logic. Higher body mass correlates directly with wider middle and lower regions of the human face. As shown in this architecture diagram, the pixel data passes through hidden convolutional layers, flowing from the PNet to the RNet blocks to isolate complex spatial patterns. Finally, a regression layer processes those spatial relationships and calculates a precise numerical score. This mathematical translation happens in a fraction of a second, resulting in a medical metric derived purely from visual patterns. The completed output appears instantly. Placed directly over the image, the blue text reveals the system has calculated a predicted BMI of 26.87. Based on medical brackets, this numerical value places the subject in the overweight category. The system then acts on that data. It automatically generates an insurance policy quote of 20 lakhs, dynamically adjusting suggested coverage based entirely on the calculated health risk. But this prototype isn't limited to processing static archival photo uploads. The system's webcam module processes live video frames, allowing it to lock onto a subject and continuously update the BMI score in real time. The algorithm operates fast enough to handle carefully staged photographs and live, unpredictable patient movements. By moving measurements from the clinic to the camera, this approach enables remote monitoring that doesn't depend on shipping physical scales or specialized hardware to a patient's home. For insurance companies, the friction of medical onboarding is reduced. They can securely verify an applicant's health profile directly through a digital interface. And for the average person, tracking personal fitness goals and monitoring daily nutritional status becomes as simple as taking a quick selfie. By mapping the specific geometry of the human face to physiological metrics, computer vision turns the standard smartphone camera into a non-invasive diagnostic tool.